from grains of sand that seem insignificant,
begins a transformation defined by precision and artistry.
At 1,600 degrees Celsius, sand is no longer just sand.
From this molten stream, countless different forms are born. Perfect marbles, durable bottles, exquisite vases, all begin from the same batch. The glass manufacturing process begins with these vast dunes of pure silica sand.
Raw silica is collected and fed into the glass plant's filtration system.
Each grain of silica must meet strict purity standards to produce clear, flawless glass.
The silica is transported to the classification area to be standardized before forming the glass batch. Soda ash is added to lower the melting temperature during glass production.
Limestone enhances the durability and chemical stability of the final glass. These three primary materials are handled separately to ensure precise ratios in the glass batch.
Silica is screened to achieve the optimal particle size for glass melting.
Soda ash is refined to ensure uniform blending in the glass batch. Metal impurities are removed to prevent discoloration and defects in the finished glass. Each limestone batch is manually inspected to meet standards for glass manufacturing.
After classification, the raw materials are stored in silos, ready for mixing into the glass batch.
Silica moisture levels are tightly controlled because they directly affect the glass melting process.
Automated dosing ensures precise proportions for the glass batch mixture.
Pre-mixing distributes the materials evenly before entering the precision blending system. The glass batch begins to develop its characteristic uniformity.
A second mixing stage ensures complete integration of all particles. High-precision laser sensors verify that the batch reaches the ideal fineness required for furnace charging. Each sample is manually assessed to confirm full uniformity before entering the melting furnace. Particle size is carefully examined because it directly affects melting speed and efficiency.
The validated batch is temporarily stored in silos before being delivered to the furnace feed. Compressed air removes remaining light impurities, ensuring the batch is fully clean before entering the glass furnace.
The completed batch is carried toward the furnace, where its first transformation will begin. This final mixing stage ensures absolute uniformity, critical for high-quality glass production. The batch flow is precisely regulated to deliver the exact quantity required by the furnace. The batch weight is continuously monitored to maintain stability in the glass melting process. This is the final stage before the materials encounter the extreme temperatures of the glass furnace. The batch is fully dried to prevent steam formation during melting. All materials converge here, the starting point of the glass melting phase. This first contact marks the transition from solid matter into molten material. Every sound in this chamber signals a crucial step in the glass manufacturing process.
Thermal imaging allows engineers to monitor heat distribution and ensure uniform heating.
Uniform distribution ensures smooth and stable melting of the glass material.
This color shift indicates that the glass forming reaction has begun.
Every parameter is precisely tuned to maintain consistent glass quality.
Only properly sized particles are allowed to enter the glass furnace. Every grain contributes to the structure of the glass to come.
Production pace rises as the batch approaches the thermal conversion zone.
This immense heat source is about to transform the entire mixture into glass.
This is the final moment before the materials officially enter the melting phase.
The heat at the furnace entrance is intense enough to distort even the light.
These rapid color changes reveal the extremely high rate of heat absorption. Temperatures inside the furnace can exceed 1,600 degrees Celsius, high enough to bend light itself.
The glass melting process requires continuous monitoring and absolute precision.
This is the moment sand fully melts and becomes molten glass.
The melting phase officially begins. From this point on, the materials begin their transformation into glass.
At over 1,600 degrees Celsius, the sand mixture begins transforming into molten glass.
The molten glass constantly stirs itself to reach perfect homogeneity.
Mechanical stirring ensures even consistency throughout the molten glass. Air bubbles are removed to ensure maximum clarity in the finished glass. As refining continues, the glass reaches a state of complete clarity. Temperature control is essential for achieving the ideal viscosity for each type of glass product. Once refined, the molten glass is guided into the forming zone. The molten glass is drawn into a thin thread before the cutting stage. Each molten droplet is precisely cut for the forming process. From here, the molten droplets begin their journey into perfectly shaped marbles.
The spiral motion shapes each droplet into a perfect sphere.
Gradual cooling preserves the perfect shape of each marble. Once formed, the marbles undergo immediate shape inspection.
Clarity and color are inspected to ensure the aesthetic quality of each marble.
Impact resistance is tested to ensure durability in real-world use. The completed marbles are gathered for the packaging stage. After forming, the marbles are packaged for distribution. Measured molten gobs are prepared for precise bottle forming. The blank mold shapes the initial base and neck of the bottle. Compressed air forms the initial hollow shape. The preform is transferred to the final mold for shaping. High-pressure air creates the bottle's final form. The freshly formed bottle emerges still glowing hot. Primary cooling stabilizes the bottle's form. Wall thickness is measured to guarantee strength and safety.
Even the smallest impurities are removed to maintain glass purity.
Automation ensures speed and consistency in bottle manufacturing.
Annealing removes internal stress within the glass.
The finished bottles are now ready for packaging.
Vases require larger gathers and more room, more intricate forming processes.
Continuous rotation prevents deformation.
The vase mold is crafted to imprint intricate designs.
Centrifugal blowing forms elegant and balanced vase shapes.
The patterns are formed through air pressure and rotational molding.
The rim is refined for a flawless finish.
Annealing ensures durability and prevents cracking.
Finishing steps create the vase's final beauty.
Each vase undergoes strict inspection before shipment.
Steady rotation helps maintain perfect symmetry in molten glass.
Air pressure is finely controlled to achieve uniform wall thickness.
Wet wood shapes and smooths molten glass without scratching it.
Pulling techniques form the delicate features of glass pieces. Handcrafted patterns elevate the artistic value of the glass.
Subtle adjustments ensure the vase maintains perfect geometry.
Timely heat correction prevents cracking during finishing.
Separating the piece from the pipe requires absolute precision.
Every handcrafted piece must be annealed for maximum durability. Polishing enhances clarity and maximizes surface reflectivity.
Only pieces completely free of impurities are approved for release.
Resonance feedback reveals the structural stability of the glass.
Laser marking ensures identity and traceability.
Finished products are fully protected before transport.
From raw sand, glass is shaped into objects of enduring beauty and value.
Each piece is a fusion of technique, precision, and human craftsmanship.
Glass is more than a material. It's the art of shaping light.
The journey of glass continues, from the factory to everyday life.